So, we continue where we left off, that is, now I want to discuss with you about the commercial instruments that are available in the country. Basically, a spectrophotometer is a low cost instrument and it gives you an unlimited number of opportunities to determine all kinds of chemicals with a wide ranging applications. So, they are available, you can buy a spectrophotometer or a colorimeter or something across the shelf, they are available. So, you should know more about the commercial instruments. Of course, lot of information is available on Google and internet, but still some basic information you are required to know. So, a number of colorimeters are available commercially, their prices range from several hundreds to several lakhs depending on the type of analysis and sophistication. At the low end are filter photometers, color comparators, and at the higher end are UV visible near IR spectrophotometers fitted with computer controlled instrument operations, capability to handle solids, colors, reflectance, fluorescence, etc. Okay. So, color comparators are the very low end instruments. Basically, they compete with our eyes. So, if you can prepare a series of standard solutions and look at their color and then take an unknown, and if the color falls in the range, you yourself can approximately estimate the concentration depending upon your experience. So, you convert it into some sort of a an instrument like a measurement of color with a barrier layer cell and a small LED and a simple filter, glass filter or something like that, they become the low end instruments. So, the color development, these are essentially non-scanning filter photometer. That means, they will give you a fixed wavelength measurement, maybe some for blue, some for red, some for green, some for yellow, some for orange, like that, and you need different kind of filters for each. So, the color development is obtained by adding the specific quantity of the reagent to the sample, which can be compared with a predetermined color chart also you can use. So, these are called as color comparators. They are adequate for rough estimates of the analyte concentration. These are useful for process monitoring or field studies, where you do not have to get very accurate analysis, but quite often we need pass or fail test. So, specific analysis, for example, in a swimming pool, somebody wants to determine chlorine, how much is the residual chlorine, and somebody wants to determine how much of gold is there in a jewelry. So, all these things are very important, but at the same time you do not need a very accurate analysis. So, for such purposes color comparators are useful, and these are the type of color comparators. You can see the black box contains two cells which I have shown on the right side, and then the filters are fixed inside at the bottom in a round plate. These are the different colors which will give you specific wavelength absorbance, and these are the type of reagents which are kept in the form of a tablet which you can dissolve and then determine. These are very low end and not meant for scientists. For routine chemical operators in a swimming pool or in a jewelry shop, etc., people use these things, and of course, they are very useful for a quick and rough estimate. The approximate cost of such an analysis would be about 75 to 100 rupees. But if you know more about the scientific things, you can reduce the cost to about 20 to 30 rupees if you know the chemistry of the systems. So, next higher end is filter photometers. So, filter photometers are useful for visible range, that is 350 to 700 approximate range. Sometimes you may see 750 or 800 or something like that, and filter photometers are essentially the the same things what we had told using interference filters or glass filters and things like that, prisms, glass prisms, because filter photometers are normally meant for visible. So, glass prism or a glass grating will do. So, it is either fitted with a barrier layer cell or a photodiode cell as a transducer. You will not find photomultiplier tubes in filter photometers. They are also known as colorimeters. The wavelength range would be approximately plus or minus 5 nanometers in such instruments. So, but the readout also is quite either absorbance or transmittance mode or in terms of concentration in recent equipments. Sometimes these in most of the recent instruments they add concentration as a third parameter for determining, which avoids the requirement of a calibration every time or calculation for the concentration. So, these are such instruments will cost you about 20 to 25,000 rupees and maybe around 50,000 rupees depending upon the sophistication, but they are useful for the low end laboratories where there is no requirement of the ultraviolet measurements. So, the readout scale could be analog or digital. So, 100 in the analog scale 100% transmittance is adjusted with 0% absorbance, 0 absorbance, and 0% transmittance is absorbed with is adjusted with absorbance of 2, that is the negative log of log 100 is 2. So, the maximum absorbance is always 2 in most of the spectrophotometric measurements. So, by simply the 100% transmittance for a reference, you have to adjust with either with the solvent or a reference solution, but also by simply changing the voltage applied to the lamp. So, in modern instruments a reference signal is stored in memory. So, they will give you only one slot for measurement of the system measurement. So, the reference is always stored in the memory, you just make your solutions and make the measurements and it will be compared with the stored memory, and then the calibration is computed and the absorbance is calculated and displayed either as absorbance or transmittance or in concentration terms. So, this is a very popular filter photometer. Here you can see 2 slots, one for reference, one for sample, and then all other things are hidden in a box, and the sample compartment is somewhere here, and then the readout scale is here, as electronics and optics is in this white box, and that also houses the radiation cell, that is tungsten lamp or whatever it is. In most of the filter photometers tungsten lamp only was being used. Nowadays they may be using LED lights with white spectrum. So, this is a LED based colorimeter, pocket colorimeter. All you have to do is put your sample here in the middle and then measure the absorbance, and it will show you as a ready made this thing. So, obviously not because of the complexity, but such things do cost quite a lot, in the range of about 15 to 20,000 rupees depending upon the requirement. So, now we go to single beam spectrophotometer. So, what is the difference between spectrophotometer and a filter photometer? So, filter photometer is used for visible range only, and spectrophotometer is used for a system which measures UV visible, ultraviolet visible and/or near IR also, that is 190 to 3000 nanometers, that is the whole range. So, single beam grating instruments are normally employed here, because as I have explained to you earlier, gratings can provide inexpensive, rugged and readily make them readily portable. These are used in quantitative analysis. The most celebrated filter photometer is Spectronic 20, which the model is available even now, and a modified version of the same thing is available in at least about 50 to 75 models available. It is a origin is somewhere around mid 50s, and modified versions of these instruments are available employing concave gratings etc. are still being offered. So, as in filter photometers, here also wavelength scan is performed with the reference solution and stored in the computer memory. The samples are scanned and ratioed. The output options include log of absorbance, logarithm transmittance, derivative spectra, overlay spectra, repetitive scan you can do, peak location, automatic search, peak height, peak area, kinetic measurements, flow through, several kinds of measurements can be made using such instruments. Single beam instruments have obviously have the advantage of the high energy throughput, because we do not have to remove the single cell, say the incoming radiation. The incoming radiation is coming in a single beam, and in double beam I make it into two beams, one for reference, one for sample. So, if I have a single beam, the intensity will be more. So, a single beam instruments always, the sellers of single beam instruments always claim that their instrument gives very high sensitivity, which is not really good, because the intensity of measurement is always halved in such cells. So, their disadvantage is baseline sensitivity. What happens is, whenever I am doing some sort of a measurement, there is always certain amount of drift. The initial baseline should be as steady as possible, but if I store it in memory, and in actual practice if there is certain amount of change in the electronics, the baseline itself will shift, but that is not recorded in the memory, because it is not an online continuous process. So, generally what we look for is continuous online basement measurement along with the original, which is split into two at the cost of a little bit of sensitivity. So, this is where the ingenuity of a buyer is required, exactly what is required in a given spectrophotometric cell. So, look at it like this, and then the double beam instruments are the next higher end, which are the current state of affairs equipments. Their range varies from 4 to 5 lakhs to 15-20 lakhs. Some instruments I have seen even up to 80 lakhs, which can measure even very thin films of metals for reflectance, absorbance, etc. And then the output of the reference beam is kept constant by employing a feedback loop to regulate photo detector. That means, any slight change in the sensitivity is adjusted by electronically for a fixed baseline length strength. So, employing a feedback loop to regulate photo detector via diode voltage, I can do that, or controlling the slit width, I can control the slit itself by using a servometer to increase or decrease the incoming light, and I can always measure the ratio of the transmitted light and initial light electromagnetic radiation continuously. These are some of the advantages for double beam instruments. So, in these instruments UV or visible radiation enters the Jerney-Turner configuration. 99% of the instruments which are coming in the market, high end equipments, use Jerney-Turner configuration, which we have already discussed earlier. The radiation is collected in the photodiode. Now, even photomultiplier tubes are not so convenient. As long as the intensities are identical, the amplifier has a high DC output, but any difference in the intensities results in an AC signal. That is a big problem at the chopping frequency. So, what happens is the unbalanced signal, it gives an AC output which is amplified and used to drive an optical attenuator into or out of the reference beam cell. So, the changes automatically occurring due to voltage fluctuation are taken care of, and they can also be used, they can also be achieved, the same thing can be achieved using a servo motor connected to this connected to a recorder, which provides a scan also. Scanning and recording are automatically included in spectrophotometers, because the scanning should be a continuous operation as far as possible. So, the servo motor also can be digitized, and computer output etc., are quite possible in spectrophotometer. That gives you unlimited flexibility in the operation. So, this is a kind of arrangement what we normally see in a spectrophotometer, that is tungsten and deuterium source, and this gets alternated up to 350 deuterium source, then this whole thing rotates and tungsten comes to the fore. So, the output is passed through a slit, a collimating mirror, a grating, a focusing mirror, and then a slit, then rotating chopper. This divides the incoming radiation into two, one for reference, one for sample, and a chopper again, and then to photomultiplier tube, and then to readout. This is only basically a schematic diagram which you should be quite familiar. Now, actual instrument, you will see not just the number of mirrors and other things which I have shown you in the earlier slide, but it will have at least about 20 to 30 additional mirrors, concave mirrors, convex mirrors, and all other things mounted on an optical flat surface, so that the signal handling and the optical movement of the electromagnetic radiation is ensured to reach the detector. Now, it is very important that such an arrangement is a very delicate arrangement, because sometimes the mirrors and other things are of about 5 to 10 centimeter squares or concave lenses, etc. 5 to 10 millimeters, not centimeters. So, 5 to 10 millimeters, and the requirement of the radiation hitting the mirror, a small mirror in a space, is so accurately required that it is almost impossible to replace the adjustment if due to any mechanical reasons the optical system is changed. So, what happens is, in 99% of the instrument, the optical system is sealed from the user. So, if there is any requirement of the optical realignment, you will have to call the service engineer. So, how do you know when to call a service engineer whether the optical system is all right or not? That we do by taking a standard sample whose wavelength lambda max is known, whose wavelength is fixed. So, these are known as primary standards, and in the primary standards potassium dichromate is 1, potassium permanganate is 1, and there are several other chemicals which will give you a peak exactly at a known place and for a known absorbance. So, the moment there is also a holmium reference cell that is standard, which you can insert, take the spectrum and compare the spectrum to a standard one, and if you see any changes, it is time for you to call the service engineer. Normally the mirrors and lenses are never to be touched with our fingers. Okay. So, that is one of the requirement, and here you can see in this figure how many pieces are there, lenses, mirrors and all other things are there. You can marvel at the total number and the complexity of the system, even though when we teach or when we learn it does not look complicated, but instrumentation wise it becomes a very specialized subject with specific applications. So, that is where I stop for the time being regarding the instrumentation. Now, we go looking for what to do with a spectrophotometer. Given a spectrophotometer, what all you can do with that is important. First thing is to find out the unknown concentration, that is number one. You can do monitoring of the spectrophotometer of the an effluent or something like that. You can use it for quality control, denoting the absorbance of a Fanta or some other drinks, etc., food and beverage applications, etc. But the spectrophotometer is basically it covers the quantitative analysis. So, how do we go about doing the quantitative analysis using a spectrophotometer? That is what we are going to discuss now. In principle, any colored solution can be subjected to a chemical analysis by spectrophotometry. You take any substance which is colored, you can make the measurement. Now, there are sometimes you come across substances which are not colored, which are colorless. Then what do? There are numerous reagents that react selectively with the analyte to give you an absorbing species. So, sometimes you may react them with a reagent, but you may not see the color also. In that case, what happens is, what is required is it may be absorbing in ultraviolet region or near IR. So, near IR means of course, you will see some slight red color, but in ultraviolet region you may not see any color at all. So, there is a vast amount of literature that exists which detail reactions of this type. So, typical inorganic reagents include thiocyanate ion for iron, cobalt and molybdenum. All the thiocyanate ions react with iron to give you a red color, and cobalt red color, and molybdenum also a red color. Now, hydrogen peroxide is another reagent, very simple chemical reactions which you can do in your laboratory for titanium, vanadium and chromium. Iodide ion, that can be used for forming iodides for bismuth, palladium and tellurium. So, there are organic chelating reagents, for example, diethyl dithiocarbamate for copper, dithiazone for lead and 1,10-phenanthroline for iron, dimethyl glyoxime for nickel, etc. So, what I want to tell you is, there is a specific reagent which you can use to determine the analyte using a specific reaction, and such reports are available for almost all the elements except radioactive elements, all the elements of the periodic table except maybe some radioactive elements, okay. And rare elements, of course, they may not be there, and some elements which we do not need for chemical analysis, but 90% of the periodic table are determined by spectrophotometry. There are certain elements like hydrogen and then helium, neon, argon, krypton and several other gases. there are not many spectrophotometric reagents, oxygen, nitrogen, you do not need a spectrophotometer for that. There are not many methods for the determination of these gases. But if it is a metal ion, if it is a semi-metalloid, if it is an organic compound, if it is a biochemical compound, they will find number of analytical methods for the determination of such analytes. Now, typical method development. So, how do I go about developing a method for an unknown substance? Suppose you are a researcher, you want to develop a method and for a matrix for which it has not been done. Even though I had told you that there are several almost anything can be determined by spectrophotometry, still you will come across challenges for which there are no preset method, no standard method available. Such things happen most of the time because the matrix is different. Now, what is a matrix? A matrix is a substance. A matrix is a substance associated with your analyte. So, the matrix, the element may contain, suppose you may want to determine gold. There are several requirements of gold measurement. For example, somebody may, a geologist wants to determine how much of gold is there in a given ore, whereas a jeweler may not need gold in an ore, but he wants to know how much of gold is mixed with copper to reduce its to reduce its carat value, 18 carat, 24 carat, like that, that is his requirement. Sometimes in electronic connections we need very small quantities of gold, and excess gold goes into waste. So, somebody wants to recover all the gold, and that requirement is different, that is in ppm level, whereas a chemist, a geologist needs to estimate gold in milligram per liter, that is ppm. A jeweler wants to determine in percentage, and an affluent man, a cost conscious electronic industry wants to recover the waste gold in ppm level, 1 or 2 ppm, maybe 5 ppm, maybe 100 ppm. So, that is the requirement. So, in each of these cases the associated compounds present in the given sample is known as matrix. So, spectrophotometry, one disadvantage is that along with the matrix the method response changes. The reaction may remain the same. Quite often the reaction will not proceed because of interferences, but still you need a method which will work in almost all matrix. Sometimes it does not happen. In that case you have to develop your own method, and how do we go about doing it? That is by doing a determination of several parameters of a given process. For example, look at the next slide. What I have written here is determination of the first thing is, suppose there is a chemical reaction giving a color, then you want to know at what wavelength is the maximum absorption. So, once you determine the wavelength for maximum absorption, I want to optimize the conditions for the maximum color reaction, maximum optimum completion of the reaction. So, what are the parameters that are influential in optimizing a chemical reaction? Obviously, they include pH, reagent concentrations, temperature, and then stability. Many of the substances are not stable for more than 1 or 2 hours. Sometimes what happens is the stability may be there for months together, for years together. So, I have to know how long a given color complex is stable on its own, and then effect of high electrolyte concentrations. You will never get substances which are having only the analyte element. There may be several other elements, electrolytes. For example, you want to determine magnesium in or zinc in sea water, the zinc or magnesium, zinc may be in ppm parts per million or maybe less than that, but it also contains 3.5%, 35,000 milligram per liter of sodium chloride. So, high electrolyte concentration is one effect which everybody would like to determine. And then sometimes you want to know the stoichiometry, what is the type of complex, etc. These are the different parameters normally we need to optimize before a method is developed. And then you also want to determine how long is the color linear with respect to absorbance, because that is the essence of Beer-Lambert's law. So, in Beer-Lambert's law, we make a plot of absorbance or transmittance versus concentration. So, that tells us in what range we should be working, because we know that Beer-Lambert's law, there are several variations from the Beer-Lambert's law at very low concentrations and at very high concentrations. And then sometimes there are other interfering substances and matrix effect, sometimes unknown associated ionic species, and all these things are possible, and we have to evaluate the effect of such things. Then determination of molar absorptivity, Sandel sensitivity, statistical evaluation of the bias is more important. For example, molar absorptivity will tell us about the sensitivity of the method, and then sensitivity is also defined by Sandel sensitivity, that is the concentration of the substance that gives you 0.004 absorbance per centimeter square. So, that is a sensitivity for comparison of different methods. So, statistical evaluation of course is very important, especially if you are handling the ores, etc., because the ores do contain a certain amount of variation in composition. Inhomogeneity is inbuilt in the composition of ores. So, there are also applications in diverse matrices. This I have already explained to you number of times. And then sometimes, suppose you have developed a method, there is certain amount of requirement of 2 or 3 substances which we want to determine simultaneously. So, what is important is there are 2 dissimilar chromophores, 2 different colors present in the sample having different lambda max and constant. Epsilon is molar extinction coefficient. So, if present in a given mixture, can we determine 2 substances in a given mixture? That is the question. So, basically the answer is always yes, we can do that. What we do normally is measurement, we make the measurement of the total absorbance of the mixture at the maximum wavelength absorbance of each complex. Then we set up 2 simultaneous equations. What we write concentration of the first substance, molar extinction coefficient of the first substance at lambda 1, that is the peak wavelength of the first complex, and then second element, molar extinction of the second element, but its absorbance at lambda 1. So, the total measurement, there will be certain amount of contribution from both substances at any wavelength. So, we write C1 epsilon 1 at lambda 1 plus C2 epsilon 2 at lambda 1 is equal to absorbance lambda 1, that is the total absorbance. Similarly, we make the measurement at the second lambda max, that is C1 epsilon 2. Remember, epsilon also changes according to wavelength. So, C1 epsilon 2 lambda 2 plus C2 epsilon 2 lambda 2 at a lambda 2 absorbance lambda 2. So, you can even call this epsilon 1 itself because obviously molar extinction coefficient will change, that is why we have put C2 epsilon 2. And then the equation this, then there are two variables and two equations, they can be solved for C1 and C2. This permits us to use two different substances in the same sample by making only two measurements. Okay. Theoretically, we should be, if we extend the idea, theoretically any number of components can be determined by using setting up simultaneous equations, but it does not work all the time. At best we can, people have tried 3 component systems, but the overriding requirement is each lambda max should differ by at least 30 nanometers. So, if the lambda max are within that, the percentage of error for each element increases exponentially depending upon the distance separated, lambda max distance separated by the different peaks. Okay, but still it has been used in number of applications and it is a wonderful technique to do it by separation, by simultaneous analysis. Then the I will not go into details, but whenever there is a need you can always come back and look up the internet and other things where you can determine 2 or 3 substances simultaneously in a given sample. The idea of this course is to give you an overview of the techniques rather than make you an expert. An expert you can become on your own after studying all the inputs. So, that is for you to absorb the ideas and then use them for your requirement. Then there is another technique that is known as differential or expanded scale, and here what happens is this is more applicable to filter photometers. In the filter photometers what happens is there is only analog scale, and as I have explained to you earlier, highly concentrated substances are prone to errors and highly dilute substances, dilutely colored substances are prone to errors. So, what we do is here we extend the range in both cases, high absorbance or low trace analysis. One is high absorbance is for higher concentration, trace analysis is for lower concentration, and maximum precision method is for concentration ranges in between the two, but you need a very high accuracy. For example, in the determination of gold, silver and several other valuable materials which require. How we go about doing this is I will explain to you in the next class. So, basically what I have taught you in this class is to the commercial instruments, what are their capabilities, instrumental parts. So, I have also taught you about the sample cell and absorbent cells, etc. Now, I have given you how the whole instrument is assembled in each case, that is number 2, and the approximate cost and functionalities of single cell, double cell and then portable equipments, etc. Now, we are studying the different methods of using spectrophotometry for pollution control analysis. Now, what we would like to do is first explore the instrumental capabilities, then we will go into the details of individual parameters. So, thank you very much. Have a good day.